and so I work with research projects. I also work at the Remaker Space, which is part of this business school, where Victor said that sorry, use my words. Yeah, obviously, as a Remaker Space, the circular economy, and also we've got lab there. Samuel mentioned Georgia University in '98. I was here in '96 when I joined for my PhD, and at the time there was one what we called a rapid prototyping machine at the time, and there was only a handful university in the UK. So that's how the research and the manufacturing started here at the university. Obviously, nowadays there's more than one machine, and we've got lots of different technologies and processes here at the university, and also obviously our research interests developed in time. So I try to characterize or kind of classify our research interests here on this slide. Okay, and obviously because they're all linked, so once you start putting your finger in one research project, and you get into the next one as well. So I'm going to start with the next slide, which is material, which is kind of obvious place to start for additive manufacturing research. And I'm just doing an overview of some of the work we've done here in materials. Most of the work in material here is done with metals. So we've had several PhD students over the years. We currently have, I think, 3 PhD students working in materials, metal powders for our plasma diffusion process, or also our binder jetting machine. So we've got some examples of some of the papers here produced on the last few years, looking at developing either new materials or recycling materials, or combining, for example, graphene here with materials for the chemical properties of the material that's to do that, we've got our initial machine downstairs, that you'll see later when you visit. The advantage we've got what's called a reduced build volume, where we can produce all the machines quite a good large build size. We can reduce the build size, so we use a small amount of powder, so we produce our own powder. So that's all research in materials. I'll just include another little video here, which is obviously not metal, but that's also an example of what we can do with polymers. I think we will the lab later on. So that was for research projects, looking at a material that was flexible, so rubber-like properties, but also magnetic. So part material that we love previously used for these projects. Unfortunately, the project wasn't funded, so if you've got an idea of an application for rubber-like material that's magnetic, then please contact me. Right, next slide is about process characterization. Obviously, Samuel mentioned some of the work using machine learning, looking at the process, quality of the part that we produce, given that from a practical or processing. We also have some projects looking more into the material science of the process, especially using cracking, for example, to the process, how we can recreate that. We've got also a team looking at microwave application, led by Jimmy Ford. She's on a project of work also on looking, for example, on monitoring surface finish on parts produced by manufacturing. Something I probably should have put there on there, but I didn't. It's some of slide. Whoops. In terms of application, obviously there's a lot of application with manufacturing. Some of the applications are not necessarily manufacturing driven, but we need additive manufacturing to complete the project. So we've got various projects where we use 3D printing or additive manufacturing to produce part of that vital for the research project. So we've got some examples here. This kind of mannequin edge here that's used for working for the project looking at respiratory masks. We've also produced what we call concrete, these little shapes here that are embedded in concrete and filled in with a liquid that helps concrete sculpting. We're also looking at another application, producing phantoms for CT scanning in order to calibrate the CT scans, depending on what kind of tissue you want to measure. You need to recalibrate for specific tissues. So what we're trying to do here, for example, is that producing 3D printed parts that have got different different densities. So we've got within them. So below there, using different materials with different densities. For example, Sam mentioned some of this. So we've got a gas and turbine research centre, which use quite a lot of metal manufacturing facilities for producing parts for burners, especially. So see when we trying to improve the efficiency of the burners. So Samuel talked about surface finishing and surface textures. What we also do here, what we've got here, this flange here is actually an internal channel inside. The channel there is there for two things. First of all, to cool the burner as it's used, so it performs better, the temperature that's more efficient. But also the gas that's used for cooling and is then used for burning. And as it's heated, also again it improves the efficiency of the burner. So we work on different design, and we've got a new design soon to do this process. And we try different also nozzle shapes and so on. Other applications, some work done by a team led by Peter Firbold in the university. He's involved with lots of research in terms of protection of the brain, so looking at helmets, for example, or NHL, or for horse riding or cycling. So developing different geometries within additive manufacturing that could be incorporated into a helmet, for example, to protect the brain. So there's a work done there also. In terms of simulation, then also some work on simulating the additive manufacturing process in the itself, especially laser fusion in metal. So we've got some examples and papers here looking at simulating the process of melting the powder, for example. Next slide is about design for additive manufacturing. So people don't normally show these pictures, see when things go wrong, and things do go wrong, and we like normally to blame either the machine or the operator, but sometimes it's also the design, so that's an area that I'm particularly interested in. So again, in order to obviously for any process, any manufacturing process, the design aspect is quite important. Obviously, you don't design it the same way. You're going to do casting, you're going to do parts being done by milling or turning, and it's not different with additive manufacturing. Although people say in additive manufacturing complexity is free, that's not really true. There are still limitations, and obviously we need to be able to design knowing these limitations. So things we work on example, surface finish, the process. On the next slide, also obviously we looked at the process itself, but we looked at the process chain. So also again done some work on strategic improvement to incorporate the whole manufacturing cycle. There's some work that we're sure also looking at the whole process, the process as a whole, and also in terms of finishing, also done some work, especially with laser polishing, for example, or laser texturing for the finished part. And finally, I think that's been my last slide. Again, try to expand the horizon again of manufacturing. We've done some work, things related, for example, to energy consumption of machines, but also some work with the schooling, the business school, also looking at other implication of using additive manufacturing. So hopefully that was quite quick. That's kind of an overview of all the different types of activities we do around manufacturing. And Mike is going to finish the presentation, this long presentation, talking about some of the